Why do I feel the way I do? I'm driven to some extent by forces that I don't understand, moods and preferences and motives which I seem to take on without consulting my will. That sentence hardly even made sense, thinking about it now. The language of my feelings is incommensurate with my rational mind. I just get the feelings, and then I hypothesize to myself what real-world considerations are implicated. I'm only guessing why I feel down at the moment. Am I lonely? Am I bored? Do I feel guilty? Am I worried about the future? Is there something my left brain has forgotten which my right brain is trying to remind me about, without the words to just say so? That's what it's like, as if I'm disconnected, disintegrated. As a result, I'm running blind. I've lost radio contact with the officer corps. I don't know what my orders are. Well, I can't stay here. I guess I'll have to take charge for myself. But I'm not trained for this. I'm on the ground somewhere behind enemy lines, and I don't have the intel from 30,000 feet. I can't see the big picture. My recent reading about octopus nervous systems got me thinking some more about split brains. It really is astounding how unaffected patients seem to be following this procedure. It's no longer just one or two patients either. The least we can do if we are serious about uncovering the substrate of consciousness is to take split brain into account. I'll begin by recounting the main thrust of what we know about split brain from research studies. I learned the most on the topic from Michael Gazzaniga, so I'll revisit his book, Tales from Both Sides of the Brain. He was talking about the patient W.J., on whom the earliest studies were published in 1962. W.J. was told to fixate his eyes on a dot in the middle of a screen. The researchers flashed a picture either to the right or the left of the dot. The patient reported that he saw it whenever it was flashed to the right visual field, but not when it was flashed to the left. The passage that follows describes the next part of the experiment. Gazzaniga writes, quote, "A circle is flashed to the right of fixation, allowing his left brain to see it. His right hand rises from the table and points to where the circle has been on the screen. We do this for a number of trials where the flashed circle appears on one side of the screen or the other. It doesn't matter. When the circle is to the right of fixation, the right hand, controlled by the left hemisphere, points to it. When the circle is to the left of fixation, it is the left hand, controlled by the right hemisphere, that points to it. One hand or the other will point to the correct place on the screen. That means that each hemisphere does see a circle when it is in the opposite visual field, and each, separate from the other, could guide the arm or hand it controlled to make a response. Only the left hemisphere, however, can talk about it." Unquote. Okay, there are further subtleties arising in different modalities that have been studied in these patients. Generally, one hemisphere is able to speak, usually the left side, and it provides us the key information we need in order to think this over. The right hemisphere feels what is placed in the left hand. The left hemisphere feels what is placed in the right. This follows from the crossed-over architecture of the mammalian nervous system. This part isn't all that surprising, right? I mean, it's cool, but it's pretty minimal in the scheme of things. The surprise is that the patient walks and talks and carries out a pretty much normal life. The eyes scan around, so it's not as if the patient's left hemisphere is forever missing information from the left side of the world. In order to find the deficit, the eyes have to be fixated to a center point, and normally we see what we put into our own hands. It takes a clever experiment just to discover that anything is amiss following split brain surgery. I'm going to attempt a brief description of what a split mind would present. Suppose we had never before carried out a split brain procedure. This was the case about 50 years ago. I don't know what the neurologists were expecting, but let's take the position that all contents of consciousness of any kind are manifestations of the cerebral cortex. And for the sake of simplification, let's take it as known that language and working memory are features of the left hemisphere. If we sever all connections which run between the right cortical hemisphere and the left, which we observe to be a rather substantial band of white matter, the corpus callosum, what should we expect? The patient awakens and recovers for a while. Then we come in to do an interview. It seems clear to me that we should expect the patient who is speaking, which is limited to the experience of the left hemisphere, to tell us that they have lost feeling or experiences of the left side of the body. that they are blind to the left visual field, perhaps even to deny that they have a left side of their body, or that there is such a thing as a left visual field. That may sound extreme, but we have seen exactly that sort of condition in neurological lesion studies. But if things were not quite so extreme, we might at least take for granted that the speaking hemisphere will be numb to sensations on the left side, that this is a new situation that the subject could report. The left hemisphere is used to receiving a lot of input from across the corpus callosum. Now it is not receiving that information, and we would expect that to be registered as different by the speaking hemisphere, and therefore as reported by the patient. But this isn't what happens. Let's see if the WADA test sheds any light on this conundrum. The WADA test is often carried out prior to major brain surgery. Its function is to determine for an individual patient the side of the brain which is responsible for language and working memory. As I said, this is usually the left hemisphere. Neurosurgeons need to know this because they want to avoid damaging these critical functions as they remove a tumor, for example. The way this test is done is by using a barbiturate, or fast-acting anesthetic, which is released into the major artery which feeds one hemisphere or the other. So they can drug the left side and test the patient's remaining cognitive function, then after the drug wears off, repeat for the right side. I watched some videos of people talking about their experience of the WADA test as the anesthesiologist is introducing the drug, a barbiturate in the videos I saw. The patient holds the doctor's hand with the hand opposite to the drug treatment and is asked to begin counting. Before long, the hand will become numb and limp. With the side that controls language inhibited, the patient can no longer speak, so the counting becomes a mumble and then nothing. In one video I watched, the patient described the sensation of being unable to find the words, like they were on the tip of the tongue. Rather than being distressed by this, the experience made the patient start laughing because it was so strange. With the anesthetized side being opposite the hemisphere for language, the patient can continue to count and answer questions. The patient would describe numbness or loss of feeling in contralateral limbs. In neither case is there a change of state, a loss of continuity in consciousness. It seems as though consciousness itself is preserved in each case, with the diminishment of certain functions and perceptions being complete and notable. So what does this tell us about the split brain condition? Let's compare two patients, each with language functioning native to the left hemisphere. One goes through split brain surgery, the other gets the right brain WADA procedure. An investigator is able to query each patient's left hemisphere in a purely verbal exchange. I recognize that this is not a perfect side-by-side comparison, but it still pulls some theoretical weight, I think. In both cases, the speaking mind is a thing of the left hemisphere, and in both cases, the opposite side is out of communication with the left, at least in principle. It would appear, however, that our two patients would answer the questions quite differently. I think the split brain patient would describe the feeling of the ipsilateral side of the body as feeling normal, while the WADA subject would describe it as feeling numb or absent. This means that a split brain cannot truly entail a split mind, doesn't it? I've got an idea. What happens if you do a WADA test on a split brain subject? Obviously, no one need suggest that the WADA test has anything to do with two minds. It is a unified mind subjected to a substantial loss of function on one side, very much like what would occur in a stroke. With the bisection of the corpus callosum, direct lateral communication from cortex to cortex is abrogated. This is undeniable. But both sides continue to be in communication with connected subcortical structures, including the thalamus. I propose that split brain surgery forces a rearrangement of communication, not a separation into two minds. And I can make a speculative claim based upon the temporally integrated causality landscape to accommodate the experimental results in this population. In brief, the TICL is composed of a large integrated system which experiences the dynamics of its subsystems. Those dynamics understood to involve a higher level of internal integration than that which occurs across the whole system are perceived in the form of conscious content. Subsystems are evaluated in terms of one another by means of nesting. Thus, a subsystem can contain smaller subsystems. If the hand is felt, and a key is felt in the hand, we should expect both to be represented, one nested in or overlapping with the other, in terms of integrated neural elements and their functioning. The elimination of direct cortical-cortical connections from right to left prevents the inclusion of elements from both sides within common subsystemic frames. This hypothesis bears repeating, if I may say so. The elimination of direct cortical-to-cortical connections from right to left prevents the inclusion of elements from both sides within common subsystemic frames. This means that occurrences in the somatosensory domain of the right hemisphere cannot be understood in terms of left hemisphere linguistic structures. They cannot co-occur within a nested manner. WJ can sense and recognize the object in his right hand, and WJ can talk about his experiences. But WJ cannot place the recognition of the object in his right hand in terms of linguistics because he is unable to bridge the gap between the two kinds of experience. He can't nest the one thing in terms of the other. His brain is unable to provide a translation between one set of existing data and another. This translation would require the two sets of data to fall within a common subsystem. It's like this. There are 2 points. How far apart are they? The answer only computes if we place the 2 points on a common line or plane. Absent this higher level representation on a common scale, the 2 independent points cannot provide us with the magnitude of their spatial relationship to one another. Or try this out. I tap you with a pencil on the back of your hand. What color is the tapping? This doesn't compute because of a lack of direct connection between those occipital networks which evaluate data streams in color terms and those parietal networks which evaluate somatosensation. If it has occurred to you that certain people have synesthetic experiences, then you understand the implications of my idea perfectly. Nobody would suggest that those of us lacking synesthesia have 2 minds rather than one for color and another for touch. By extension, neither do those patients who lack left-right cortical connections. For the TICL, the time it takes to integrate a set of elements is critical to forming a subsystem. I propose that the amount of temporally integrated causality for a subsystem must exceed that of the whole system. Temporally integrated causality is the amount of causality over the time it takes to achieve it. It stands to reason that it would take longer to integrate elements across the 2 hemispheres when the direct connections are no longer present. But indirect routes may still be an important part of the integration process for the thalamocortex. I wondered as I was making notes for this episode whether there had ever been EEG studies looking at coherence between the cortical hemispheres in split-brain patients. I found a recent paper called Integrity of Corpus Callosum is Essential for the Cross-Hemispheric Propagation of Sleep Slow Waves, a high-density EEG study in split-brain patients by Giulio, Avvenuti, et al. in the Journal of Neuroscience. This is just the kind of study I was looking for. To what extent is the measurable activity in the right and left cortices rendered independent by cutting the corpus callosum? The authors write, quote, "The transition from wakefulness to sleep is marked by profound changes in brain EEG activity, with a shift from the low-amplitude, high-frequency signals recorded in wakefulness to the high-amplitude, low-frequency, slow waves of non-rapid eye movement sleep. In particular, the sleep slow wave represents the EEG signature of a slow oscillation in membrane potential at neuronal level, characterized by an alternation between a hyperpolarized silent phase and a depolarized phase of intense firing activity. Crucially, the amount of slow wave activity represents a reliable marker of homeostatically regulated sleep need and has been shown to be locally modulated in a use-dependent manner, thus implying a possible relationship with plasticity-related processes. Indeed, experimental studies and computer simulations have demonstrated that not only does slow wave activity reflect experience-dependent changes in regional synaptic density and strength, but slow waves may also play a direct role in cellular and systems restoration and in the consolidation of newly acquired memories. Recent evidence also suggested a possible implication of sleep slow waves in the clearance of neurotoxic metabolic products that accumulate during wakefulness." Unquote. They go on, quote, "The sleep slow waves are not stationary events. Instead, they typically behave as traveling waves at the macroscale level of the scalp EEG, with variable cortical origins and propagation patterns. Such a propagation is commonly assumed to reflect the structural properties of cortico-cortical white matter connections. In line with this, structural white matter properties have been found to correlate with parameters reflecting slow wave synchronization. In this perspective, the corpus callosum would be expected to represent the main route responsible for cross-hemispheric slow wave propagation." Unquote. According to the title of the paper, the corpus callosum is essential for the propagation of sleep slow waves between the hemispheres. Here is a short passage that sums up their results. Quote, "Here we demonstrate that the cross-hemispheric propagation of non-REM slow waves largely depends on the integrity of callosal white matter tracts. Indeed, while in healthy adult subjects more than 60% of all slow waves showed a clear cross-hemispheric propagation, in calosotomized patients, more than 60% of them remained confined within the cerebral hemisphere in which they originated. These results are in line with previous correlational evidence, indicating a direct relationship between parameters reflecting slow wave synchronization and the microstructure of the anterior corpus callosum. More in general, they provide support to the hypothesized relationship between patterns of slow wave propagation and structural cortical-cortical connectivity." Unquote. Largely dependent, they say. Non-REM slow waves showed clear propagation across the hemispheres in 60% of cases in the control group, but in less than 40% of cases in the split brain group. That is a reduction of 1/3. I would hardly call that the elimination of something essential. Most of the slow wave propagation is conserved even without the corpus callosum. That means there's another route, and it is a major one. This result is consistent with the subtle cognitive anomalies shown in split brain research. These same cortical networks project back to the thalamus and to subcortical centers which feed both hemispheres. Perhaps there is only one mind in these patients after all. Folks, you heard it here first. I'll repeat my hypothesis. The elimination of direct cortical-cortical connections from right to left prevents the inclusion of elements from both cortical hemispheres within common subsystems. There are not two minds. There are coexisting contents of consciousness which cannot be evaluated in terms of one another. They are like points on separate planes. As far as I know, this explanation of the split brain phenomenon has never been articulated anywhere. More than that, it depends upon something like the TICL as a theory of consciousness. It doesn't appear to me that integrated information theory could accommodate this hypothesis. I think IIT would support the claim of two distinct minds in accordance with two isolated maxima of integrated information, and I think this hypothesis is testable if the right kind of experiment were contrived and carried out in split brain patients. Then again, it won't be. As far as I can tell, nobody listens to me.